In this video, I'd love to discuss how to take the derivatives of all sorts of trig functions. And I want to, at first, I'm just going to help it make sense. I'm going to explain to you in my weird little brain how I've made the connections, and hopefully those same connections will work for you. So I'm just going to talk you through this table, and I'm going to notice some interesting things, and it's going to help you kind of strengthen those connections and see how they're all sort of related. All right, so first we're just going to dissect the table. Then we'll do like a bunch of examples with the table following us along. And as we take the derivatives of different trig functions, we'll make sure to apply the chain rule. By the way, I have a video on the chain rule. I'll put a link at the end if you need to see that for a better refresher. Okay, so let's get into the trig relationships, and then we'll get to the examples. All right, so first couple you've probably learned are the derivative of sine is cosine, and the derivative of cosine is sine. So the first key idea that I want to call to your attention is anytime you take the derivative of a something with a leading c, whether it's cosine or cotangent or cosecant, you'll notice that the derivative, the right-hand column, has a negative. So the derivative of a yields a negative. I'll just write that out like super conceptually, and that I did that in blue. The derivative of cosine, cotangent, or cosecant has a negative in the result. So that's our first observation. Our next observation is anytime you have the derivative of something with a tan, whether it be tangent or cotangent, you'll notice that the result yields a square. So the derivative of tan, there's going to be a squared in your answer. The derivative of a cotan, there's also a squared in your answer. So if you're taking the derivative of a tan, the result will have a square. Okay, so two observations so far. Now you'll notice that I kind of broke this up into three chunks. Our table is in three chunks. Well, you'll notice that tangents, buddy, and that, again, this is how it is in my brain, tangents, buddy, is secant. So anytime you take the derivative of tan, you just get your secant, buddy, but it's squared. So the derivative of cotangent, kind of will apply that rule right away. The derivative of tan is secant, and since it's a tan, it's squared. The derivative of cotan, well, since it's there's going to be a negative, and cotans, buddy, is cosecant, and since it's a tan, it's squared. So you'll notice in this region, tan is paired with secant, therefore cotan is paired with cosecant. So if you think about this buddy idea, makes me think of an old movie, this buddy idea, the derivative of anything with a tan yields a squared. The derivative with anything with a yields a negative. But so for tan or cotan, you're just going to have its secant buddy squared. Tan's secant buddy is secant. Cotan's secant buddy is cosecant. So that kind of takes care of these two right here. The derivative of tan is secant squared. The derivative of cotan is negative cosecant squared. So we're applying both of those ideas. So sort of tan and secant are buddies, and cotan and cosecant are buddies. Okay? So that's a key idea. You'll notice as well, when you take the derivative of anything with a secant, whether it's secant or cosecant, you'll have itself multiplied by its tan buddy. You have itself, meaning you have secant x. The derivative of secant x is itself secant x multiplied by tan x. The derivative of cosecant x, again, it's itself. Oh, there's also a negative because it was a co. You're taking the derivative of a co. It's itself times its tangent buddy, which happens to be cotangent. So when I say tangent buddy, cosecant's tangent buddy is cotangent. Tangent's buddy is secant. So wait, let's say that. Cotan, again, goes with cosecant. Tan with secant. So anytime you take the derivative of a secant, this one arrow, the single arrow means take a derivative, you're going to have itself multiplied by its tan buddy. Thus, we have completed the table. So let's highlight the three ideas one more time. Anytime you take the derivative of a co, the result is a negative. Check. Anytime you take the derivative of anything with the word tan in it, or t, you'll have the result, the derivative. Its secant buddy is squared. Since it's a co for cotangent, you'll have a negative. And its secant buddy is cosecant, and it's squared. Anytime you take the derivative of secant, you have itself times its respective tangent buddy. Also, again, if it's a co, the result is negative. So this might sound weird, but I want the tangent buddies in your head. Practice writing this table over and over again until it is tattooed in your brain. Flashcards are really good. I know that's old school, but it works. All right? So we have the handy-dandy table. We followed along, came along for the ride, and now we're taking the derivative of our first example. The derivative of tan of 6x squared. Well, the derivative of any tangent function is its secant buddy squared. Now the inside is going to be unchanged, but then, since we have a composition of functions here, we have 6x squared jammed into tan x. We'll have to take the derivative of the inside by the chain rule. The derivative of 6x squared is 12x. So again, the derivative of tan is its secant buddy squared. Don't forget the chain rule. So put a little check mark. We did that one. All right. Next up, we have the derivative of cotangent of x to the third. All right, well, the derivative of a co, that's going to yield a negative. The derivative of a tangent is its secant buddy squared, which in this case is cosecant squared. And then we have to remember to chain it. Multiply by the derivative of the inside, which is 3x squared by the good old-fashioned power rule. All right? And we'll put a check mark there. Perfect. And another one. DJ Khaled's here today. All right? So here we have a derivative example with the product rule, but we're still sneaking in the derivative of a trig function. So you have to have your eyes peeled in calculus because you're going to take the derivatives of, you need to know trig derivatives, and it's going to show up in quotient rule, product rule, chain rule, and a partridge in a pear tree. It's going to show up all over the place. So here we have the product rule. Quickly, that's the first times the derivative of the second plus the second times the derivative of the first. I like to set myself up like that organizationally. I have a product rule video. If you want to check that out, please do. So it's in my calculus channel. So I have 5x to the third. That's the first. The derivative of the second, well, the derivative of tan is its secant buddy squared. Notice there's no chain rule here because we just have x being plugged into the function. And then we have the second times the derivative of the first, which is 15x squared. All right, we had the power rule. 3 hopped in front, got decreased by 1. 3 times 5 is 15, x to the second. All right, very nice. And here we're back to good old chain rule. I guess we could put a little check mark. We did tan there. Okay, so here we are. The derivative of secant. Well, the derivative of secant of stuff, this is what I'm calling stuff, x squared plus 9x. The derivative of secant is itself times its tangent buddy. Secant's tangent buddy is just straight tangent. So we don't have x here. Our input is x squared plus 9x, so we have to make sure that that's the same on both. Different input, therefore different output. Okay. And now we can't forget our chain rule here. So we almost have taken this derivative. We just need to make sure that we multiply by the derivative of the inside, which is 2x plus 9 by the power rule. The derivative of x squared is 2x. Derivative of 9x is just straight 9. So this may be uncomfortable. Please make sure that in place of x is now x squared plus 9x. And that really, as you experience the chain rule, with that chaining, you still have to multiply by the derivative of the inside. All right, so that's a pretty good one. Oh, cosecant. Whoop, we're taking the derivative. The derivative of co is negative. With cosecant, you're going to have itself and its tangent buddy, which is cotangent. But now your input is not x. Your input is 5x squared minus 9. Similar vibe to the last question. So those are multiplied together, and then you've got to chain rule it. The derivative of 5x squared minus 9 is just 10x. So again, we had the negative because it was a co. We had itself because it's a secant. We had its cotangent buddy or its tangent buddy. Make sure it's cotangent though. And then we have the chain rule. Bada bing, that's our final answer there. So I hope this video was immensely helpful. Again, take time to write it over and over again and have those silly words in your head because it's going to stick long term. It's been sticking in my brain for over 20 some odd years. All right. Derivative of a co is negative. Derivative of tan is its secant buddy squared. And the derivative of secant is itself times its tangent buddy. Thanks for watching. Feel free to hit me up in the comments. Tell me how math is going. Drop me a follow. Give me a like, if you would, please. Thank you. Have a beautiful day.